Lisp is the second oldest programming language still in wide use. Today we're going to talk about where it came from and why it's been so influential. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
All right, Dave, this week we want to know all about Lisp. And let's start with the beginning. What is Lisp?
Lisp is a programming language that was invented in 1958 by John McCarthy. Now, he was already an influential person in computer science. He had coined the term artificial intelligence just a couple years before. He worked with a team below him that implemented the language, which included a gentleman named Steve Russell, who also created the first widely distributed video game called Space War. So it was quite an influential team working on this first version of the language. When Lisp came out in 1958, it had some features that no other programming languages had had before, and we'll get into those today. But Lisp isn't just a single language, it's actually a family of languages. There's a bunch of languages that we still use today, like Scheme, Clojure, Common Lisp, and Racket, that all have been derived from that original Lisp and highly inspired by it and really resemble it in most ways. So Lisp is still with us today, and that's why we call it the second oldest programming language still in common use, the first being Fortran, which was invented a couple years before it.
Let's dive into what makes Lisp special. Besides longevity, there are some really interesting features of it.
Yes, probably the most special feature of Lisp is what's called homoiconicity. This is the idea that code is data. You can manipulate code in the same way that you manipulate data in the programming language. That's pretty interesting because it means you can actually manipulate your own program as it runs. You can actually treat code and change code while the program is running from within the programming language. So you can actually have self-modifying programs or programs that manipulate other programs. This leads to all kinds of interesting possibilities, and there's many creative applications of this idea. But that's not all that's special about Lisp. Lisp was the first language to introduce automatic memory management. This is now a very common feature across most modern programming languages. The idea of automatic memory management is that the programmer doesn't need to worry about allocating a certain amount of memory and then deleting that memory when they're done with it. The programming language has a runtime that takes care of allocating memory and deallocating it for the programmer. This reduces memory errors made by the programmer and also in many ways makes programming more fun because there's one less thing that you need to think about, one less overhead for you as the programmer. Another important feature of Lisp is that the whole language is built on the data structure of a list. Now, that's the reason it's called Lisp. It originally stood for list processor. So everything in the language is actually a list. So when you have, let's say, a function, it's actually structured in the form of a list. And when you have some data, it's generally structured as a list. And when you have a declaration of a variable, it's going to be expressed as a list expression. Everything is a list. And this goes back to that idea of all the code also being data, because the language knows how to process list data. And since all the programs are lists, it knows how to process programs as well.
That's really cool. The other thing I've heard you talk about with Lisp is that it uses prefix notation.
Yeah, so this is pretty easy to explain. So we're used to, when we do arithmetic, infix notation. So you're used to writing expressions like 4 plus 5 with the first operand at the beginning, then the operator, the plus sign between the two operands, and then the last operand at the end. In Lisp, you would actually write that as plus 4, 5. This is also sometimes known as Polish notation, where we see the operator before the operands. It turns out that structuring a language with prefix notation makes it easier to process, both for us to build the initial compiler or interpreter for the language, but also for manipulating the language at runtime. This whole idea of homoiconicity. So the whole language is based around, first, here's the thing I want to do, and then here's the things I want to do it with. This confuses a lot of programmers who are coming from other programming languages when they first see a Lisp-like language. They often get kind of intimidated by the fact that it looks so different. And we'll talk in a minute about another way that it looks really different. But just this whole way of thinking of first, here's what I want to do, and then here's the things I'm going to do with it, is quite different from most other programming languages that, at least for math, tend to use infix notation as we do in arithmetic. So another really unique feature of Lisp syntax is the use of parentheses. Every list is actually enclosed in a set of parentheses. And I told you that all of the language structures are actually defined using lists. So what you end up with is lists inside of lists inside of lists, and all of those lists have parentheses around them. And so you end up with a huge number of parentheses embedded within one another. And it's not unusual to see a Lisp function that ends with like 5 to 10 ending closing parenthesis brackets. It's crazy. And this alone sometimes makes the language hard to use if you're not using a good editor. You want to be using a text editor that knows how to match parentheses automatically for you, so that before you go and try to run your program, you can know if you had matching parentheses in all the right places. One of the most common problems I see new programmers who are using Lisp have is that they have trouble matching up all their parentheses. There's just so many that it's hard for the human eye to kind of keep track of where one begins and one ends and where they match up. And so having a really good editor is really critical. They didn't always have that. If you go back to the early days of Lisp, they wouldn't have had the same kind of modern editors we have today that can do a lot of this for you. So this alone actually turns off a lot of people from Lisp. Now, we've talked in a previous episode, which I'll link to in the show notes, about what is a programming language. I talked about in that episode how syntax is really only skin deep. It's what a programming language looks like. It has less to do with how it works. In the case of Lisp, though, because the syntax is so tightly coupled with this idea of homoiconicity and making it easy to process the language as data, it means that actually the syntax really does matter. And at the same time, though, the syntax matters in another way, which is how it turns off programmers from using the Lisp family of languages. Unfortunately, this actually turns off a lot of people, and there's a lot of people who don't want to touch it just because of the syntax.
It's had such a long lifespan because it is so useful. So where is it being used?
John McCarthy, who originally designed it, I mentioned earlier, was highly involved in artificial intelligence. It's not a coincidence then that Lisp was one of the first languages used in the field of artificial intelligence, and it was highly influential within that field and still used widely within it all the way up to the 1980s. And still today, there's still people who do AI research in Lisp. So that was one of its strongholds for many decades. Today, it's used in a wide array of different areas, everything from web development, although it's not that popular in it, but there are some web frameworks and some diehard supporters of those web frameworks, to back-end processing for data manipulation, and also still for some interesting AI research and applications. So it's found a wide array of different uses, but it's also been very influential on other languages. In particular, the idea of automatic memory management and using lists as a central data structure has been seen in many other programming languages as well. There also are some very well-known practitioners of Lisp for whom Lisp has been very influential on their careers. I'll mention just a few of them. Paul Graham, he's known for starting the incubator Y Combinator and also being a successful startup founder himself, is a big proponent of Lisp. He's even created his own Lisp dialect that he promotes. Another one is Richard Stallman. So Richard Stallman is the founder of the Free Software Foundation. He really started the free software movement. We talked about him in our episode on open source software. He created a version of the Emacs text editor that has a Lisp dialect as its macro language, as its like internal language called Emacs. And so he's a proponent of Lisp and a very well-known person in computing. Another one is Eric Raymond. He is also involved in the open source movement, which is, if you listen to our open source episode, is kind of competitor to the free software movement. And he's really espoused the benefits of Lisp as well. So there's a lot of well-known people who are involved with Lisp, including a lot of people who've been in AI research over the decades as well. So it's probably punched above its weight in terms of it's not the most popular language in the world, but some of the people who use it have been highly influential. And it has to do really with the way it makes you think. Just how different it is, both syntactically and also in terms of this idea of homoiconicity, as you program really makes you think about ways of solving problems in different ways. And then even if you don't go on to use Lisp for the rest of your career, you might take some of those ideas with you to the language that you tend to work in day to day.
Well, in the 80s, weren't there some machines that were made for Lisp?
Yes, there was actually a movement in the 1980s for what are called Lisp machines. These were machines that were designed from both a hardware and a software perspective to be fully built around the Lisp programming language. So they were really like optimized for programming in Lisp. There were several different companies, and they were somewhat influential in the 1980s, but they all died out. There was something called the AI winter, there was kind of like a bubble and excitement in AI, and then people realized, well, you know what, maybe a lot of this is ahead of its time. There's not a lot of practical applications right now for it, and a lot of that died out. And with that kind of AI winter, I think a part of that was these Lisp companies going away, because like I mentioned, Lisp was highly tied to the field of AI for many decades. So yeah, there was whole computers built around the idea of being good at working in this programming language, and those companies went away as Lisp kind of went away. By the 1990s, Lisp was not that popular, and it really seemed like it was something of the past. But there's been something of a renaissance over the last couple of decades, new dialects of Lisp that are really gaining traction. One of the most popular right now is called Clojure. It's built on the JVM. It can actually work together with Java. So people who work in a Java-based environment can easily integrate Clojure into their workflow. And I think that's one of the reasons that Clojure has been popular, is that it's kind of the best of both worlds if you're into both Lisp, but also into working in a modern enterprise environment.
Would you encourage a new programmer to learn Lisp?
Yes, I absolutely would, because of the way that it'll make you think differently. So it's actually used to be very common in introductory programming courses at the college level to use Lisp, in particular a dialect of Lisp called Scheme. In fact, when I was in college, our second programming course was in Scheme. There's a famous book called The Structure and Interpretation of Computer Programs. It was written by two MIT professors, and it serves as an introduction to programming in the Scheme language, which is a dialect of Lisp. It was used across many college campuses for decades. It still is used today. I think recently Scheme has kind of died out in its academic popularity compared to where it was maybe a decade or two ago, but it's definitely still used. And so the reason it's used so much in academia is really, yes, it expands your mind as a programmer. It makes you think about programming in a different way. And you're likely to come away with that thinking, you know what, I don't know if I want to program the rest of my career in Scheme, but there were some things I learned programming in Scheme that really are going to change how I program in Python or Java, etc. And I'll just also add that that's something about Lisp, is it tends to be kind of sometimes thought of as an academic language. It is very popular, these different dialects in academia. Are they always the most practical languages? Maybe not. They don't always have the best performance characteristics. Sometimes they're missing some powerful features that other languages have, but that doesn't mean they're not used in industry. So Clojure, which I mentioned earlier in particular, is breaking out into industry in certain niches. So I wouldn't say that Lisp is a wholly academic language, but I will say it has more of an academic flavor than maybe your average programming language does. Well, there's a lot more we could say about Lisp. We could talk about specific things like how it's dynamically typed, or the different kinds of list operations that generally exist within it. But I think this high-level overview is enough to get people interested, at least. If you're not a programmer, you probably don't want to go any further. But if you are, I really recommend that you check out a language like Scheme or maybe Clojure and get a sense of how it differs from what you use day to day and how those ideas that we talked about today, like homoiconicity, might be powerful. The last thing I'll say is it's interesting how much you can do with just a single data structure like the list, right? The list internally is typically implemented using a linked list, and those of our listeners who are programmers know what that is. But it's amazing how flexible and how powerful just this single data structure can be. We can build a whole programming language just around the idea of linked lists. And these languages tend to be very good, these dialects, at processing lists. So you'll see that they have all kinds of specialized built-in functions for working with lists. And when you go and you use these languages and then you go back to your Python or your Java, and then you're using a list in those languages, you might be kind of missing some of the power of list manipulation that exists in the language called the list processor. All right, well, thanks for listening to us today. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
And don't forget to hit follow. Sometimes we do more technical episodes like we did this week, and sometimes we do more general purpose episodes like we did about choosing an internet service provider a couple weeks ago. We look forward to seeing you next week.
Thanks for listening.